Alright, today we're going to solve various questions on indices, but before we just begin to solve the questions, I would like to um, go through the general laws in indices, just in case this is the first time you're coming across this topic. So I think it will be very important you know the laws first before we begin to solve a little bit more complex questions. So these are the laws, the general laws of indices. The first one is the multiplication law. So you see, this is a raised to the power n. Now this is the general case, right? So it's not as if we're just going to be using only a. We're saying any number raised to power any power m times a raised to power n. So the what you must take note of in the first law there is that it's the same base, right? This the first base is a, the second base is a, then they are raised to different powers, but once the bases are the same, just when you add the powers. Division is exactly the opposite. So once the bases are the same, you subtract the powers. Now the third case, any number raised to the power 0 is equal to 1. Any number at all raised to the power 0 is equal to 1. The next one is what we call the fractional index, where the index in the case we are considering is going to be a fraction. So you see the denominator becomes the nth root while everything is raised to power m. There is also another way of representing this law, but I like to go with this. Then the last one is a raised to power any negative number. This is a negative index law. Alright, if you want to write it without the negative index, it's going to be 1 over a raised to power m. So you need to know these laws. I think they'll be very helpful. So let's solve the question. Now the next thing I want to say is that in solving question on indices, the first thing that should come to your mind always, you see that most of these laws are, in fact, even beyond the laws, but most of these laws apply when the bases are the same, especially the multiplication and division law. So when you're solving a question in indices, the first thing that should come to your mind is how you can get the bases to be the same throughout the question if possible. So that's the first thing you should look out for. That's the mindset you should have immediately solving a question involving indices. I want all the bases to be the same. In this case now we have h raised to the power 2n equal to 1 over 64. Now every number there I want it to be in the base 8 or the base 4 or whatever if it's possible. Thank God 64 can be written in the base 8 because 64 is equal to 8 times 8, which is equal to h raised to the power 2. So I can now rewrite this expression as h raised to the power 2n is equal to 1 over h raised to the power 2. I've changed nothing in the equation. I just replaced 64 with h raised to the power 2. So now we're going to use one of the laws. H raised to the power 2n is equal to, now I want this 8 everything on the left hand side of the equation to be on the same line, if I will use that word, everything on the right. So I want to change this 1 over 8 squared, to, I'm going to change it to h raised to the power minus 2. Now the law I've used here is this last law here. We say that if you have a negative index, you can remove the negative index by putting 1 over the positive index. So I can go back and forth. In this case is a positive index but as the denominator. So if I bring it back, remove the 1, I'm going to put negative 2, which is from this law. So basically we're going to be playing around with the laws. So if you're new to this topic, I would like for you to just pause this video, go through these laws again and again until you internalize it. When you internalize these laws, everything becomes relatively easy. So now back to the question. We have h raised to the power 2n equal to h raised to the power negative 2. Now for this to be an equation, which I'm saying it is because this question was saying that whatever is there is equal to whatever is there. So if the bases are the same, which is obviously the same, 8 is equal to 8, then the powers must also be the same. So since we're looking for n, we're going to equate the powers. We're going to say that means 2n must also be equal to minus 2. Now to get n, we just divide both sides by 2. So n is negative 1. Negative 2 divided by 2 is negative 1. So if you know the laws of indices, you keep the bases the same, indices should be very simple for you, especially, or rather at least, some of them might be tricky. They are not difficult. It can just be a tricky question, but hardly a difficult one. Alright, let's continue. So I have another question there. So we should find the value of x if the whole of that. So remember, the first thing that should come to your mind is, how can I get all the bases to be the same? Well, the least base here is 3, so I'm going to check whether I can write all these numbers in the base 3. So of course you know that 9 is equal to 3 times 3, so I can write that in the base 3, and 3 times 3 is 3 raised to the power 2. Keep it in index form because we're dealing on indices. The next number there is 27. 27 is 3 times 3 times 3. So 3 times 3 times 3 is 27, and that's also equal to 3 raised to the power 3. So I can write everything in the base 3. So I think I'll just put the laws again. So remember these laws, so we're going to be using them to solve. So let's replace 9 with 3 raised to the power 2. So that will be 3 raised to the power 2. However, you see that we have another power there. So 9 is 3 raised to the power 2, and then we also have another 2x raised to the power minus 1. So we have 3 raised to the power 2 raised to the power 2x minus 1. Okay, times 3 is just there, so we just have the same thing. And it's equal to 27 is 3 raised to the power 3 raised to the power x plus 3, because we can't throw this x plus 3 away. Now I think there's another law I did not put, because I'm seeing another law here. That law is what we call the power law. If you have a raised to the power m, raised to the power another value n, for instance, this is called the power law. It's going to be a raised to the power m times n. So you're going to multiply the powers. So that one is called power law. So just add it to the laws that you're internalizing. So we're going to apply this here. You see that we have 3 raised to the power 2 raised to the power that. So that's going to be 3 raised to the power 2 times 2x minus 1. Now just write everything again. Then on the other side, we also have 3 raised to the power 3 times x plus 3. So it's always good to put, whenever I have two terms, put it in the bracket, so you remember to distribute the 3 to both terms inside the bracket. So let's expand here. This will be 3 raised to the power 2 times 2x will be 4x. 2 times negative 1 is negative 2. So that's what we have. We just write everything the way it is again. Then this is 3 times x is 3x. 3 times 3 is positive 9. So now we have 3 common. So let's just use another law of indices. So you see this is 3 raised to the power the whole of that times. So this is multiplication law. So we're going to use this law here. When they are the same base, which is obviously 3 and 3, we add the powers. So this will be 3 raised to the power 4x minus 2 plus 3x plus 1. So we are taking this base and this base, and we are just adding the power. That's the multiplication law. And the whole of that should be equal to 3 raised to the power 3x plus 9. So let's simplify finally. So we have collecting like terms here. You see this 4x and this 3x. 4x plus 3x is 7x. So I have 7x. Then we have negative 2. You see this negative 2 plus 1. So minus 2 plus 1 is minus 1. So I have minus 1. Let me write that again. Sorry. Alright, and that is equal to 3 raised to the power 3x plus 9. So let's go ahead and simplify. So now you see that we have 3 raised to the power 7x minus 1 equal to 3 raised to the power 3x plus 9. So again, we're going to say, okay, for this to be an equation, if the bases are the same, the powers must also be the same. So we're also going to have 7x minus 1 must be equal to 3x plus 9. So just collect like terms. So 7x, if I move 3x, it becomes negative 3 on the other side, equal to 9, crossing 1 the other side. So you see in this case, I cross 3 this side and I'm crossing 1 the other side, but anything that must cross the equality sign will change sign. So negative 1 becomes plus 1. So 7x minus 3x is 4x. So we have 4x equal to 10. So just divide both sides by 4 to get the final value. X is equal to 2 into 10 is 5, 2 into 4 is 2. So we have 5 over 2, but since it's not a proper fraction, we can write it as 2 whole number 1 over 2. So that will be the value of x for this question. Now let's look at another question here. So it said solve for x if 2 raised to power 2x plus 1 minus 9 times 2 raised to power x plus 4 equals to 0. Now this is already pointing to something, because you know that an equation that is equal to 0 is most likely going to be a quadratic equation, right? So let's see how we can bring out the equation from this. So now you see we have 2 raised to power x. So let's see how can we simplify the whole of this to get that 2 raised to power x. So we're going to do something there. We're going to say this is 2 raised to power 2x times 2 raised to power 1. Now the whole of this is still the same thing with this. All right, I just splitted it, because if you do the multiplication law, you're still going to get, if you do that, you get 2 raised to power 2x plus 1 if you add the powers again. So I'm just trying to break it down. You know, these laws of indices, you can go back and forth, so I'm going the other way around this time. So you have to just take note of that. All right, so minus 9 into 2 raised to power x plus 4 is equal to 0. Now I can break 2 raised to power 2x down further using the power law. I can say that is 2 raised to power x raised to power 2. If I simplify this, see that this is power law. We're going to multiply the powers. X times 2 is 2x. So it's still the same thing. So you see, I'm not changing anything. I'm just breaking it down further until I get what I really want to get. So I'll leave that like that, and then say times 2. 2 raised to power 1 is still 2, minus 9 into 2 raised to power x plus 4 equal to 0. Now I have you see that I have 2 raised to power x here, I have 2 raised to power x here. So I can now draw an equation. I can say, okay, let 2 raised to power x be equal to anything. It can be equal to a, b, c. So let me just let it be equal to a. So wherever I see 2 raised to power x, I'm going to put a. So let me write the equation. So this will be 2 raised to power x. I'll replace it with a, raised to power 2. A raised to power 2 times 2 minus 9 into, I have another 2 raised to power x there, so I'm going to replace it with a, then plus 4 equal to 0. Now I can simplify. 2 times a raised to power 2 is 2a raised to power 2 minus 9 times a is 9a plus 4 equal to 0. Now we have a quadratic equation, and then we're going to check if we can factorize. Hopefully it's factorizable. So anytime you want to factorize the quadratic equation, you take the coefficient of a squared and multiply it with the constant term there. So we have 2 times 4, which is equal to 8, and then you see the constant is positive, so we have 8. So we have 8. Now we're going to look for what are the 2 factors of 8 such that when we add them we get -9, and when we multiply them we get 8. Let's list the factors of 8. We have 1 times 8, we have 2 times 4. Yes, these are the factors of 8. Now these are the only factors of 8. There are 4 factors of 8. So we're going to ask ourselves, which of these factors will add up to -9? Of course, there is no way you can add 2 and 4 to give -9, so this is out of the picture. Now how can we do that for 1 and 8? You see that -1, -1 plus -8, this will go on to give you minus, so that will be -1 minus 8 will be equal to -9, and then -1 times -8 is equal to +8. Minus will be plus. So the 2 factors we're looking for would be the factors would be -1 and -8, because that's what suits our situation. So we're going to use it and solve. So now we're going to replace 9a with the factor. So we have 2a raised to power 2 minus 1a, remember the factors are -1, then minus 8a plus 4 is equal to 0. Notice we didn't change anything in the equation because minus 1a minus 8a will still give us what we have in the original equation, which is minus 9a. So the idea of solving a quadratic equation in this way is just to find a way to break down that middle term so we can now factorize everything by grouping, using the common term. So that's just the whole idea behind it. So let's go ahead and finish up the calculation. So let's group that now. Let's put them in a bracket. So I have 2a squared minus a is same thing as 1a, minus. Now anytime you put a negative sign in front of the bracket, change the sign inside, please. Very important. So this was positive 4. Now I'm writing negative 4 because this negative times this negative will give you positive if you open the brackets. So that's why. Alright, so the common term in this bracket, the first bracket is a. So we have a cancelling 2a squared will be 2a, minus a into a is 1, minus common term here is 4. 4 into 8a is 2a, 4 into itself is 1, and that's equal to 0. So we have factoring again, we have 2a minus 1 times a minus 4 rather, is equal to 0. So let's solve for a. So if this times this is equal to 0, it can only be so when one of these is 0. Remember, it's only when you multiply a term by 0 that you get 0. So if this times this is 0, one of them must be 0. So we're going to equate it. We're going to say, okay, 2a minus 1 will be equal to 0, or a minus 4 is equal to 0. So we can get two values for a. So in this case, we have 2a is equal to -1 crossing is 1, so that we divide both sides by 2. When we divide both sides by 2, you see that a is equal to 1 over 2, or a is equal to, if we move 4 the other side, it becomes positive 4. So finally, our values of a is half or 4, and that's the final answer. So a is half or a is 4. So this is the breakdown. All you need to know is to know the laws of indices and then know how to apply them, and keep practicing, and then it becomes very easy. So thank you for watching.